Okay, so this question says, given the following reactions, calculate the H for this reaction down here. Now this reaction down here is our goal reaction, so we can manipulate any of these equations to be able to form this bottom equation down here. So the first step I'm going to do is I'm going to take this top reaction and I'm going to flip it around. And when you flip reactions around, you also have to flip the sign of the H. So first I'm going to do 2CO2 plus H2O yields C2H2 plus 5/2O2. And these reactions are already balanced, so it makes it pretty simple. And then the heat becomes just 13,000 because we flipped the sign since we flipped the reaction. And then next, I'm just gonna balance out this. So I'm gonna multiply this whole equation by 2. So 2C plus 2O2 yields 2C2. And whatever you do to the reaction, you also have to do the heat again. So this heat would be negative 788 kilojoules. Okay, and now the bottom reaction can pretty much stay the same. So you have no manipulation to do on the bottom reaction. So H2 plus 1/2 O2 yields H2O, and the specific heat just stays the same, equals negative 286 kilojoules. Okay, and we want all of these to be able to match our goal reaction, so I'm just going to write it down here so it's easier to see. So 2C plus okay, and now we know that when crossing out like our things, they have to be a product and a reactant, which is why we manipulated them and flipped them around the way that we did. So the 2CO2 crosses out right here, the H2Os cross out right here, and then 5/2O2 cancels out with this. This is basically 4/2. So these cancel out, and then plus 1/2 is 5/2. So these all cancel out together. And then that leaves you left with the bottom reaction that we need. And H2. Okay. And now to find the heat, we're just going to add up everything on the side. So let's add all this together. And that gives you 226 kilojoules. And it's positive, not negative.